Okay, so this is going to be all about isosceles and equilateral triangles, and you need to remember that isosceles triangles are the ones that have two sides the same, and equilateral are the ones that have three sides that are congruent. So let me grab my notes and get you started. And I'm just going to work on getting that paper situated. Okay, so these are some practice problems that we'll do in a minute or two. And then for the notes, we have, ta-da, we have this. Okay. What did you say?
What they doing tomorrow?
No, yes, this is what they're doing tomorrow. Absolutely. Okay. So let me grab my pen.
So I will be
Yes, you will be ahead again. That is so right. Okay. All right, here's my pen. I'm ready to go. So I'm just going to read some definitions to you because you have to know these definitions to be able to do what we're learning. I will use and apply properties of isosceles and equilateral triangles. Okay, so I talked about that a second ago when I said the isosceles have two sides that are the same and the equilateral have three sides, right? All right.
Yeah.
So on an isosceles triangle, I'm going to just draw a quick one right here. An isosceles triangle, you can think of it sort of like a shape of a teepee, like the Native Americans lived in teepees, or like a capital letter A sort of. And in that, these two sides here that are congruent to each other, those two sides are called the legs. Those are called legs. So over here, excuse me, I'm gonna write.
I know.
What did you say?
That is kind of funny.
That's kind of funny, yeah. The sides of an isosceles triangle that are congruent. Okay, and then okay, this is the word base. So this is the other side. I don't know why I said the wrong thing. I'm sorry. This is vertex angle. The included angle between the two sides that are congruent. So let me get you a drawing, and I'll use this drawing right here. This is a leg. This is a leg because these are your congruent sides. This angle right here is called the vertex angle.
Yeah.
Okay, so that vertex angle is the angle that's in between the two legs that are congruent. Now, the side at the bottom between the two legs on the other side, this is called the base. And then these angles here and here, these angles that surround the base are called base angles. So the base angles are going to be congruent. And the easiest way to tell which angles are the base angles is to trace from the congruent sides. So you see how I have the two notches for the congruent sides, like right there and right there? If I trace through the interior to the angle that is across from that, I get to this angle right here. And I trace this one through, and I get to that angle right there, okay? So the angles that are across from those congruent sides are congruent angles, okay? All right. And then that's really the rest of the definitions that are at the top. So I'm just not even going to finish filling those notes out at the top. We just did it on the triangle. Now, the isosceles triangle theorem says if two sides of a triangle are congruent, then the opposite angles are congruent. And the converse of that says that if two angles in a triangle are congruent, then the opposite sides are congruent. So basically saying it backwards, it's also true. Okay. So that is just a sentence about what I just showed you on the figure. So let's just go back to the drawing and make sure we understand what it's saying. It's saying that if you have two sides marked congruent, then the opposite angles will be congruent.
Yeah.
If you have two angles congruent, then the opposite sides will be congruent.
Yeah.
Okay. Then there is another theorem. Sorry, my paper keeps scooting around. I'm kind of zoomed in a little too much. Let me back up a little. Okay. So the equilateral triangle theorem says that if all three sides of a triangle are congruent, then all three angles are congruent. And you could say that one backwards. So if all angles are congruent, then the sides must be congruent.
Yeah.
Okay. So all that one is really saying is whenever all of your sides are congruent, then all of your angles must be congruent. So basically, if it's equilateral, it is also what? What's that other word? If it's equilateral, then it must be also Yes, good job. All right, so now let's move on. So we're going to work problems using those facts, okay? So before we even start to work the problems, let's just look at the triangles for a moment. I'm going to kind of zoom in on the triangles and let you see them really well. So on this first one, do you think that's isosceles or equilateral? Do all the, if all the sides look the same and all the sides have a mark, then it would be equilateral. So it's not, right? It's isosceles. Yeah. Now let's look at this triangle. Exactly. You got it. Okay. So now we're going to work some problems with these. Okay. So on this first one, notice how they've labeled it with this goofy little, it's like the angle is so tiny that they know they can't write the number inside of there. So instead of writing the number inside, they make this little mark to show that that's the angle. Okay. So it's 22 degrees for that angle right there. And then the other two, we're going to have to find them because in the instructions it says determine the measure, right? This means measure of angle F. And if you look at the diagram, angle F is one of the ones at the bottom, okay? So these are our two base angles. And remember, when it's isosceles, if you have a pair of congruent sides, then the opposite angles are congruent. So this angle and this angle are congruent. So those two angles at the bottom, those base angles are the same measure. Now, here's how you do it. You use your triangle sum. How many degrees are in the interior sum of all three angles? What is it? 180. 22 is just that one angle. But 180 is the interior angle sum. So if you add up this one plus this one plus that one. Yeah. So we can do this just with numbers, or we can write an algebraic equation with variables. Which one do you like better, to do with numbers or with variables? Okay, so if we're going to use a variable, then they want us to solve for the angle at F, so I'm going to make that an X, okay? Which means that this one over here is also the same thing, x. Because remember, the base angles are congruent to each other. And then all three angles add up to how many degrees?
180.
Exactly. So you can write an equation that says x plus 22
Equal 180.
exactly. Now, what do I do with that?
My wife.
You were so awesome with combined like terms. You never forget. I'm so impressed with you. Okay. Now, what do I do?
Mine.
Awesome. Yeah, exactly. So then I have 2x equals, do you know what 180 minus 22 is? Let's do it together in our head. What's 180 minus 20? Yes. Did you do it in your head or did you use a calculator?
I knew it.
You're so awesome. Okay, so now what? All right, I'll do it.
I don't know what that equals.
All right, so I'm going to, I'm just going to do it over on the side real quick, okay? 2 into 15 is 7. And then 7 times 2 is 14. So I'm going to subtract and then carry 1 down. 2 into 18 is 9. Okay, so it's 79. There we go. Now, let's see. We found x is 79. That would give me this angle is 79 and that angle is 79. And they said find the measure of angle F. So we did 79 degrees. Okay. Do you see how this says justify? That's basically a fancy word for saying, how did you think this through? So we could say that we used X to represent both of these angles because the base angles are congruent. And then we used the triangle sum to add them all together and set that equal to 180 and solve. Okay.
Yeah.
All right. So let's do, I'm looking to see what I want to do next. Okay. Let's do this one. Hold on just a second. Yep. Okay. This one right here. This. What did you say?
Can we go?
You want to do all of them? Okay. I guess we can. I was looking at example 2. I just know that we won't have one like this on our test. This question right here is more difficult than your test. So I was going to skip it. You what? You want me to do it or no? Yes or no?
Yeah.
Okay, let's do it then. So you see the 2 marks to show that the sides are congruent here and here.
Yeah.
And remember what we do with those is we trace it through to the opposite angle. So if I go through the inside of the triangle to the angle across from that side, it's this one right here. And now I'm going to do the same thing with the other mark, go through the triangle to the opposite angle, and it's that one right there. So those 2 angles are the base angles. This triangle is kind of upside down from the first one we looked at, right? Because the first one we looked at let me see if I can turn it right side up for you. It looked like this more, right? Where the 2 sides were like this and the base angles were at the bottom. So these 2 angles have to be congruent. So I could just set those 2 things equal to each other and solve it. Okay, so let me turn my paper back to right side up. Okay, so that's 6y equals what?
only AY minus 15.
Nice. Okay. So then I have to solve that. What would you like me to eliminate first?
AY 15.
Awesome. That's right. It's 8y you want to do first, because if you eliminate that term first, if that term was not there, you would have all the y's on one side and all the numbers on the other side, right? So that's definitely what you want to do. So let's do minus 8y minus 8y. And then 6 minus 8 gives you how many y's? Are you stuck on that negative?
Negative.
Good. Negative 2y equals, and then this is 0, and I carry down negative 16. Now what?
The one.
Good. Okay, so divide by negative 2 on both sides, and I'm left with y equals, now I have to do negative 16 divided by negative 2. Good. Then it says find the measure of n and m. So if I go back to the original triangle and I look, here's my n. So plug it in, right? So 6y would be 6 times 8. So n is 6y equals 6 times 8 equals 48. Okay. So now if n is 48, then so is p, because those are the base angles, so they're the same. If I want to find out how much m is, what can I do? I could use my triangle sum, Connor. I could use my triangle sum like I did in the previous problem, where all 3 of the angles have to add up to 180. So I could just put an X here, and I can do 48 plus X equals 180. And then 48 plus 48, that's 96. And then minus 96. And I get X equals, I think that's 84. Yes, that's 84. Okay? Okay.
Yeah.
So this problem, the last part of it, this very last part right here that we just did, is just like the first example, really. The difference is that on the first example, you had an X for the base angles and you knew what the vertex angle was at the top. On this one, you knew what the base angles were and you had to put an X for the vertex angle. So they're the same idea of using the 180 sum. It was just different about which angle they were telling you.
Yeah.
Okay, so let's look at the next two. The next two are using equilateral triangles, okay? So you'll notice that we have the 3 sides marked congruent. That's why I know it's equilateral. That's what you were saying to me earlier when we looked at it. Now, if all 3 sides are the same, then all 3 angles also have to be the same. So how many degrees does one angle have to be if all of the angles are the same?
180.
It's 180 for the whole total, right?
Yeah.
So what if I let one of these angles be y? Then each one of them is a y, right? So y plus y plus y is 180. So 3y is 180. So y is 60. So one of the angles has to be 60 degrees. Okay? So every angle is 60. Now they're telling you that this angle right here is represented by 2x plus 32 degrees. But you know that it has to be 60 degrees because it's an equilateral triangle and all of the angles are 60. So what you can do is you can just write that expression equals what? Yep. So we're going to write 2x plus 32 equals 60. Now, what do I want to eliminate? Good. Okay, so I'm going to subtract 32 on both sides. And then I'll have 2x equals 28. And yes, exactly. And then I have x equals 28. What's half of 28? Good. I heard a beep come over the video or the sound on the computer. It sounded sort of like a beep from a smoke detector or a beep from something battery is dying. Was it on your side? Did you hear it a moment ago? No?
No.
Okay, don't worry about it then. If we hear it again, I'll remind you about it. Okay, so if x is 14, let me see if that's, yep, all they wanted was find out what x is. So that one is done. X is 14 degrees.
And do you want me to go?
Do I want to go what?
Do you want me to go?
Go ask?
Yeah.
Only if we hear it again. It was probably nothing. I just heard a sometimes things, electronics make sounds. So I just wanted to make sure that it wasn't anything important, but I bet it's not. We'll just wait and see if we hear it again. Okay. Determine the value of JL. So okay. So JL is here. So I'm going to highlight that. Okay. So they want to know how long is that side there. Okay. So you see the variables, right? We should probably write an equation with the variables and solve that. And when we solve it, it will tell us what T is. And then if you knew what T was, what could you do with that? Exactly. And since it's an equiangular triangle, since all the angles are the same, if it's equiangular, it's also what? Yeah, that's true. But I was saying if it's equiangular, it's also equilateral.
Yeah.
Every equilateral triangle is equiangular, and every equiangular triangle is equilateral. So if it's equilateral, then what equation do I write? How do I write an equation with this and that? What do I do with them? Nope, I'm not going to add them. Those are the side lengths, not the angles. You know, sometimes we add together the angles, but not the sides. So let me go back to the beginning of what I was explaining a minute ago. If all of the angles are congruent, then so are the sides. Because if it's equiangular, then it is equilateral. And equilateral means this side and this side and this side are all congruent. So what equation can I write? Not add them, but what?
Equal A.
Nope, because that would be for the angles, not for the sides. You can equal 180 with your angles, but these are sides. We can set them equal to each other. If it's equilateral, that means equal side lengths. So I can set what?
Equal sideways.
Equal side lengths, exactly. So I can set this equal to that. I can write
Yeah.
2t plus 1 equals 4t minus 8. Okay, so let's work that. What would you like me to eliminate?
No.
Okay, so minus 1, 2t equals 4t. What's negative 8 minus 1?
-9.
Good, okay, now what?
No.
Well, if I add 9, let me think about that for a second. If I add 9, that's going to remove the 9 from here, and I'll still have a t on both sides.
No.
Hold on. Don't you want to get rid of this t so that you can have t's all on the same side and numbers all on the other side?
Yeah.
Yeah, you got to get rid of this. Okay, so minus 4t minus
One.
t. Okay, so now 2 minus 4 is
-2.
awesome. So negative 2t equals, this cancels itself out, and I bring down negative 9.
No. One.
Yes, now I divide. Did you notice that this is going to have a fraction for the answer? So that eliminates, and I get t equals, this is negative 9 divided by negative 2. So basically, what is 9 divided by 2? What's half of 9?
Wait.
What's half of 8?
4.
Right. And half of 10 is 5. So half of 9 is halfway between 4 and 5, which is 4.5. Okay?
4.
4.5. Yeah. So this is how much T is. They want us to say the value of JL. So JL
Yeah.
is this whole side here, which was represented by 2T plus 1. So plug it
Yeah.
in. Yep. So JL equals 2T plus 1, and that equals 2 times. Okay. So what is 2 times 4.5?
Oh my.
2 times 4 is 8. 2 times a half is 1. It's 9. 2 times 4.5 is 9. And 9 plus 1 is 10. So JL equals 10. Now, if we want to be sure that we're right about that, we could also plug into this one. So we would have to do 4 times 4.5 minus 8. And that, let's see, so 4 times 4.5 is 18. And 18 minus 8 is 10. So yes, that is right, because I got 10 for the other side. So we got the right answer. Okay, so now let me show you what practice looks like. We're going to do one more problem together because you can get a little bit more complicated than what we did. Let's do this one right here and then we'll be done, okay? See this one that says number 7 right there? This is a lot like a problem that is on the test, on the quiz. So we need to do this one to make sure you understand. So you see how this is 2 triangles right next to each other. And you see these marks. And there's another one over here. And there's also a right angle mark. Okay? All right. So we have to start with numbers that we know. So we have to start with this triangle here. Okay? And in that triangle, we know that this angle is 69. And we have these two sides marked congruent. So we'll do the same thing we did earlier. We'll trace it through to the opposite angles to find out what the base angles are. So here's one base angle, and then here's the other one. So that means the other one is also exactly. So now I can use my triangle sum of how many degrees? How many degrees? Huh?
9.
69 and 69 plus this angle here will be how many degrees total?
180.
Awesome. So we're going to write 69 plus x equals 180. So if I add together 69 and 69, let me do that over here on the side. $138. I'm sorry it got out of focus. Let me see if I can fix it. Okay, there we go. I got 138. So I'm going to put that right here. And then I have to subtract that, right?
Yeah.
So 180 minus 138. So I'm going to go over here again. Okay, 42 for x. Okay, so now I'm going to put that on the triangle where it goes. It goes right there. So I'm going to put a 42. Okay. All right, so now the next thing I have to do to be able to work this triangle is use the right angle. How many degrees in a right angle?
9.
Yep. And so if I have a 42 on this side of this line here, then it's 42 plus this angle here equals 90, right?
Yeah.
I'm going to write 42 plus, and I'm going to call this one y since the other one was x, okay? 42 plus y equals 90.
Yeah.
So now minus that 42, and I get y equals, now I have to do some more math. Let me come over here. 90 minus 42. 40, sorry, 48. Okay, so 48, and that one is right here. Okay, so now let me put the whole triangles where, all the triangles where you can see them. So I have a 48 here, and now I'm trying to work on this triangle on the side. So now I'm going to look at, let me change colors with my highlighters. Now I'm going to look at these two sides being the same. So this triangle, now this angle and that angle match, right?
Yeah.
Angles. So if 48 is here, then 48 is.
Yeah.
So now last step, I've got 48 plus 48 plus this one equals 180. Okay? So one
Yeah.
equation. 48 plus 48 plus x equals 180. Now if I add 48 plus 48, I get 96. 96 plus x is 180. Subtract that. So now I need to do 180 minus 96. Mm, 84. All right. So 84. Were you saying 184? You were close. It's 84.
I meant that.
Yeah. Okay. We finished. We got all the angles. My goodness. So that's a lot, right? There will be a problem like that on the quiz. So let me put it, I'm going to try and put it, and I don't know if you noticed this, but I didn't realize they had an X here for the last part of the problem. And we had, I wrote X on that one that we started in the beginning. So let me change that over to be a Z. Just so we don't have X in more than one place. Okay. So now I'm going to zoom this out and put all of it on screen where you can look at it and see everything, okay? So let me cover up this other diagram. So in the beginning, we did 69 plus 69 plus Z. I changed it to Z. 69 plus 69 plus Z is 180. And we solved for that Z and we got 42. And we put that 42 right here. That was the first thing we did. After we did that, we looked at the 90 degrees right there. And there was the 90-degree mark. So then we said 42 plus y is 90. And we wrote this equation. And we solved and we got y is 48. And we put the 48 there. Then the next thing we did was we said, well, this is also an isosceles triangle. So the base angles of this triangle have to be congruent. So this one is 48 and this one is 48.
Yeah.
And then last time we did 48 plus x is 180. And we got 84 for the last angle right there. So we had to do 3 equations to solve that triangle. Okay. All right. I'm going to go ahead and stop our recording. And